The quickest way to get the software going is to bring up a previous test. It's convenient using a database to have a test that was done maybe a year ago and to bring up the same test to start a comparison test on the same audiometer. There is data entered into the audit database. This is part of the startup and maybe the most tedious part of using the software. Is you'll go in, create a new database and a new measurement and save those items. And as a part of the equipment setup, you enter in all of your instrumentation. So the Model 824 meter and its serial number and calibration due date, along with the preamplifier, the microphone, the calibrator. These are all entered into the database and tracked with the audit software on the PC. Once that's all entered and you're ready to make a measurement, you can just tell it to go ahead and make that measurement. We'll bring in a demonstration measurement for today by retrieving that measurement. The important thing here is to go to Equipment Setup and just verify which earphone we're using. In this case, we're using what's called a TDH50 earphone. This one appears in the standard. They're very specialized earphones, and they have exacting characteristics that they're supposed to meet, depending on the coupler that's being used to test them and the model of the earphone. You can see a number of different models that we can bring in corrections for. And there's also different couplers that you can use then to test the earphone. We mentioned briefly the RET-SPL, and you can actually, if you have a unique earphone that you want to try, that you can go in and change those reference equivalent threshold sound pressure level numbers away from the standard number to match maybe a special test item. So now we can go to the measurement. Right now the audit software is setting up the 824 sound level meter to the proper mode and gain and settings. And the first thing it wants us to do is check the calibration. So I'm actually putting that black CAL250 calibrator over the microphone, and we're watching the measured sound pressure level coming in the window. Ideal would be 114.0. If you get it to 114.0, we can probably continue. We don't need to make any changes. If for some reason it's off by a little bit, then you can go ahead and do a set calibration. Typically, this equipment is very close, within a few tenths of a dB, day to day, day after day. It's very impressive that it can hold those kinds of stability with the acoustics. As we look at the hearing level, if we use 250 hertz as an example, as we select that, we can measure selected. As we go ahead and hit measure selected, the software prompts us to set up the audiometer now, turn the dial to 70 dB hearing level, and set the frequency at 250 hertz. What I'd like to do for the demonstration is just leave the calibrator on over the microphone, which we know is supposed to be 114 dB sound pressure level. And we'll tell this OK and measure my calibrator, which is over the microphone at this point in time. And it brings in the level of the calibrator at 114.0 measured sound pressure level. It turns out at 250 hertz that exceeds the target sound pressure level of 99.5, so audit software puts in a red X indicating that at this point the test has failed and you may need to retest or substitute a different earphone. Something in the system isn't working right. In this case, the calibrator is over the microphone, which is telling me that the calibrator and the microphone and equipment connection is good, as I'm coming in with the 114 dB level for troubleshooting. We can go down to next test. It prompts me to save some data, and I'm telling it, no, I don't care to save this data. And as it sets up the next test, then again, we could hit Measure All. With Measure All, the system starts at 125 hertz and will automatically step through all the frequencies. It also prompts the operator to set the proper dB hearing level, in this case 80 dB hearing level, to do the frequency tests as the standard requires. At this point, I think we'll bypass that. I think you're starting to see how it's mostly a step and repeat. If one item fails, you can go back and mark that particular item and do a measure selected to home in on that particular problem at that frequency. But as you'll note here, we'll go on to the next test. The test is becoming quite an extensive test. In next test, they call a narrowband noise. If you take your FM radio and put it off station, you can hear somewhat of a white noise. Definition of white noise is equal energy per hertz. And we can also get a narrowband noise, which goes up in frequency as we change our frequency meter. So we go to the next test. There's again the broadband noise. That's the white noise, as commonly referred to. And then the last test would be speech. The audiologist would actually have a CD or a tape that they can play back through the audiometer. This speech test or speech noise is typically a phrase or a group of words spoken in a certain way, which they then use as a modified speech to see if their subject can identify a few words. Again, better to qualify the hearing loss as they're testing the individual. Okay, that's our hearing level with a supraoral earphone. We can also go and do the bone vibrator, again with the AUDit testing. Some clinics are set up with a nice sound booth, which would have speakers mounted in the booth, and so there may be speakers to test. The insert earphones can also be tested, and the last one in the list is called the circumaural earphone. They're a little more specialized. These are also sometimes referred to as the high-frequency earphones, as they will go up and accurately produce the 12,000 hertz and some of the higher frequencies that they may be interested in testing.